Hello students, welcome to Saraswat's classes. In this video, I will be solving the following question from ISS 2017 paper 4. Now here we have that in multivariate analysis, often the issue of handling too many variables poses a big problem. So how do we solve this problem? Now, when there are too many variables, that is when the model is when there are too many variables, that is when the model is overfitted, it causes many problems, such as it results in misleading regression coefficient, then misleading p-values and r-squared statistics. So this overfitting of the regression model, or having too many variables, it may result in wrong or misleading regression coefficients, p-values and r-squared statistic. So we have to solve this problem to avoid these situations. We have to solve this problem. So the measures to reduce the number of variables, to reduce the number of variables. The first one is to remove the highly correlated predictors from the model. To remove highly correlated predictor variables from the model. Now what happens is, sometimes in the regression model, suppose it is yi is equals to beta naught plus beta 1 x1i plus beta 2 x2i, so on till beta m xmi. So suppose it is our regression model. Here sometimes it is possible that two or more factors, they are highly correlated, that is they have a strong linear relationship with each other. What we do is that we remove some of them from the model, that not all but some of them from the model, because these correlated variables, what they do is they supply redundant information. So removing one of the correlated factors, it will usually do not have any drastic effect and reduce the r square. So what we are doing is that we are removing the highly correlated predictor variables from the model, because sometimes in this model there are two or more variables which are highly correlated to each other, and so they supply redundant information. So what we have to do is we have to remove some of this highly correlated predictor variables. Now this removal, it can be done by using stepwise regression method. method or best subset regression method, best subset regression, or some specialized knowledge of the data, or some specialized knowledge of the data to remove these variables, and we should select the model that has highest R squared value, that has highest R square value. So the first method is to remove the highly correlated predictor variables. However, this R square value, it would increase every time we add another variable. So instead of this selecting a model that has highest R square value, we select the model which has highest adjusted R square value, because this adjusted R square, it would only improve if the new variable it has a considerable effect in the model. So we can use the following methods, that is stepwise regression method, best subset regression, or specialized knowledge of the data, any of these methods, to select a model that has highest adjusted R squared value. Now this is the first method, and the next method is to use partial least square regression, partial least square regression. In short form, it is called PLS, or principal component analysis, or principal components analysis, because this is a regression method. It is a regression method that cut the number of predictors to a smaller set of uncorrelated components. So this regression method, that is a partial least square regression or principal components analysis, it cuts the number of predictors to a smaller set of uncorrelated components, to a smaller set of uncorrelated components. So either we can use any of the following methods, like stepwise regression, best subset regression, or the previous knowledge, specialized knowledge of the data, to reduce the number of correlated variables, or we can use partial least square regression or principal component analysis to cut the number of predictors into a smaller set of uncorrelated components. So these are the methods by which we can reduce the number of variables, that is, we can remove the problem of overfitting of a model, or that is to solve the problem that are arised due to the overfitting of a model.